This is an example of a stack modeled as an array. This is the stack class, and you'll see it has two attributes. One of them is an array of strings. This array is of length 10. This is not normal, this is not practical. Usually it would be a lot bigger than 10, but since I have to draw it on the screen here, I made it a smaller one. We have a top. This is an indication of where is the top of our stack, and we started out at -1, and I'll explain why later. So the constructor just creates a new stack and a top. Then we need a pop, which takes something off the stack. The push puts something on the stack. The peek looks at the top element of the stack. It doesn't put anything on, it doesn't take anything off, it just looks at what is on the top. Empty returns a true or false depending on whether this stack is empty or not. Full returns a true or false depending on whether it's full or not. Full is really only needed when we have an array, because we use it before we push something on our stack, and an array has a finite length. So if I'm going to put something on it, I need to make sure that there is room for it and we do not have a full stack already. So I would check to see if the stack was full before I did a push. Similarly, I would check to see if something is empty before I try to take something off it. And we use this all the time, no matter how we are modeling the stack. We always want to know if it's empty before we try to pop. Otherwise, we'll get an error. So let's see how we can use this stack. And I have just 6 operations here to do. We're going to push high, we're going to push 2, we're going to pop, then we're going to push at, and then a pop and a pop. So we'll start out with this push. We're pushing high on this stack. So our push starts at line 22. It says S of top plus 1. Top is -1, so top plus 1 is 0. S of 0 is high. So here is my 0. And I'm going to put my high in here. And this is at element 0. And I recognize I'm not putting the double quotes around it. You have to assume those double quotes. It's just easier for me to draw at this point. So that is line 24. Now line 25, top plus plus, so top becomes 0. And what this is saying is that you'll find the top of the stack at element 0. In other words, this is the top of our stack. That's what it's saying. So that's the results of the push. Now we have another push. Push 2. So another push says S of top plus 1. Top right now is 0. Top plus 1 is 1. S of 1 is 2. TO. So S of 1, so I'm going to put the 2 in here. That's line 24, and then line 25, top plus plus, so top becomes 1, and it's saying this. You'll find the top of our stack at position 1. Then I have a pop. Line 17, S of top goes into X. Top is 1. S of 1 is the word 2, and that goes into a variable called X. Here is X, so the word 2 is going to go into it. Top minus minus, top becomes 0. Which means that top now points here, and not here. And then on line 20, return X. So pop returns something. Push does not, but pop returns something, and it returns the string at the top of the stack, which is the string 2. Then I have a push, and you'll notice that top now points to the 0th element. Now the word 2, the string 2, is still in our array. That's okay. It doesn't matter. The important thing is that the top of our stack is at the 0th element. Now I'm pushing the word at. So we'll go to push. Push says S of top. What is top? Top right now is 0. So I'm pushing. So S of top plus 1. Top is 0. Top plus 1 is 1. S of 1 is 80. So no longer that, but our new string AT. And then line 21, top plus plus, which says top is now 1. So our top now points here and not here. So at this point, we have 2 things in our stack. The top one is at, beneath that is high, and the top is telling us, the variable top tells us which is the top of our stack. If we asked right now if it was empty, the answer is no. Empty would return false, because top does not equal -1. Top equals 1 at this point. So top equal -1 is false, and this empty, the method called empty, will return false. Similarly, full will also return false, because top is 1, which is not 9. So top equal 9 is false, and full will return false, empty will return false. And if we look at our stack, that is correct. So now we pop. Pop says X is S of top. Top is 1. S of top is this word AT. So that is now X. Line 18, top minus minus. So top now becomes 0, which means that this is now the top of our stack. Whoops. And not this. So high is now the top of our stack. And then line 20, return X. So this pop returns 80. And then I have another pop, and my other pop says X is S of top. Top is 0. S of top is high. And top minus minus, top becomes -1, which means it is not pointing here. And then return of X, return X. So this returns the high. And just looking at this code, you can see the last in, first out nature of a stack, because push high, push 2. So the last thing that went in was the 2, which is the first thing that comes out. I've still got the high on there, then I put the at, and then I pop. At was the last one in, first one out, and then all I've got left is the high. So hopefully this explains to you how this stack works when it is modeled as an array, and you need to understand the reason that top started out at -1. And right now I have an empty stack and top is -1. Now we're going to use this stack in a program, and this program is called StackAsArray. So we start out creating a new stack, and we're using the user-defined stack class from before, a stack of strings. And we ask for a string, and we collect it and put it into this string object called S, and we will add it here. And we can see here that we have this string called S with value 0. We declare another string called C, and now I am ready to put these strings on this stack. So as long as C is S.substring from 0 up to but not including index 1. In other words, the very first element of this string, which would be the uppercase H. I could have used car@, but that would have made C into a character, because car@ returns a character. And this is a stack of strings, so I really want C to be a string. So the string that is the very first alphabetic character in this string. And now I'm going to push it onto the stack. So it goes into the stack right at the bottom here. This is the 0th element. So I have labeled the stack according to because it's an array, according to the indices of the array, and I put my H in at the 0th element. And now S gets altered. S is now the substring that starts at index 1 and goes to the end. So S is now going to be ERO. So we see here that S is now ERO. That's coming from line 29. I go back up to the top of my loop. S is not empty, so I go into the loop and I get the next substring, which would be this lowercase e. That took care of line 25. Now I move to line 27, where I push C onto the stack, and C is this string containing the lowercase e. I have my E on my stack, and now S is altered. S now starts at index 1 and goes to the end, which means it consists of R and O. And this brings me to the bottom of my loop. I go up to the top. Is S empty? It is not, and therefore I go into this while loop again, and I find C is the substring starting at 0, going up to but not including the 1. In other words, C is the lowercase r. Now I need to push C onto the stack. That brings me to alter my substring. So S is now lowercase o. That takes me, well, to the bottom of my loop, which takes me up to the top. S is not empty, so I go into my loop again and I find the substring starting at 0, going up 2, but not including 1, which is this lowercase o, and that goes in as the value of C. Now I push C onto the stack. And now S is the substring starting from index 1 and going to the end. Well, index 1 is actually empty because that O is at index 0. So that brings me to the empty string in S. S is now empty. That takes me to the top of my while loop, while S is not empty, but actually S is empty. So I'm done with my while loop, and I go down now to line 35, which makes C the empty string. So I've just started C off again here as the empty string. Line 37, while your stack is not empty, pop it and concatenate it with C, and that's the new value of C. So if I pop this, it is the top of my stack, which right now is at index 3, that is popped. So this is popped, and that O is concatenated onto the null string that C started out as. So stack is not empty, so pop it and concatenate it with C, and that's the new C. So pop it, concatenate, it's not empty, pop and concatenate, that was an E. It's still not empty, so pop and concatenate. This point, my stack is empty, so I'm done with this while loop, and I can print the string reversed is C. And this looks a little messy, so let's just tidy it up a bit. So this was this line that I hand wrote, but I made it a bit tidier here. It was the empty string concatenated with the O, the R, the E, and the H, which becomes this. And it is hero in reverse, and that's what would be printed out. The string reversed is OREH. And that's the use of a stack to reverse a string.